The last part of section 6.4 deals with special techniques for factoring polynomials. Now these techniques will maybe only be used 15 to 20% of the time, but it's something that you need to see and be able to recognize. The first technique that we're going to talk about is the sum or difference of two cubes. Now if you notice what I'm underlining in red, I have the sum of two cubes, a cubed plus b cubed. And if you have a polynomial that's in this form, there's just two terms, but they're both cubes, and they're added together. The factors are equal to a plus b is one factor, and then the other factor would be a squared minus a times b plus b squared. You can rewrite it as these two factors. Notice I color-coded the a's and the b's. If it's a difference of two cubes, again, it will be a binomial. They have two terms that are cubes, and then you write the factors as a minus b and a squared plus ab plus b squared. Again, if you notice, they are color-coded. Now, these are formulas that you can use to actually do your factoring for you if your problem is in this situation. Now, I'm going to do one example for you that's going to demonstrate how to do this. So if you need to pause the video, please do, but otherwise I'm going to go on and do this example. Here's a problem right here. Factor completely. 64x cubed minus 27. Now the first thing I'm going to notice that 64 is a perfect cube. That's 4 to the third power. And I'm going to notice 27 is a perfect cube. That's 3 to the third power. So really, I could rewrite this problem if I really wanted to. I could write it as 4x to the third power minus 3 to the third power. Now, why did I do this? Because in my prior formula, it says that if you have a to the third minus b to the third, that's equal to a minus b, parenthesis, and then a squared plus a times b plus b squared. Now, if you notice, this 64x to the third minus 27 fits this form. And 4x is really the a value, and 3 is really the b value. So all I really need to do is substitute this in. So 64x to the third minus 27, its factors are, the first one is a minus b. Well, a is 4x, so I'm just going to plug 4x where the a is. That goes in there. And 3 goes in where the b is. So that's my first factor. My other factor is what a is squared. So that's 4x, and I'm going to square that, plus, and then a times b, well, that'd be 4x times 3. So I'm going to go 4x times 3 plus, and then the b is 3, and I'm going to square that. So now all I have to do is simplify. This becomes 4x minus 3 is the first factor, and the second factor would be 16x squared, because 4x times 4x is 16x squared, plus 3 times 4x is 12x, and last is plus 3 squared, which is 9. And what I'm going to underline in green, this will not be factorable. So therefore, in the box are my two factors for this special case. This was a case a cubed minus b cubed, and those would be its two factors. Now, if you have further questions about that, please ask me in class. But that's case number one, special case number one. Special case number two is to factor by grouping. Now, this works, factor by grouping works for cubic polynomials, which you're going to see in a second. But the way it's going to work is very simply. You're going to group the first two terms together, and you're going to group the second two terms together, and they're going to have a common number that can be pulled out front. So I'm going to pull out the a, and I'm going to be left with x plus y. And over here, I'm going to pull out the b, and I'm going to be left with x plus y. Now, if you were to redistribute, you'd get back what I'm starting with where I point my arrow at. And last, since both terms have an x plus y, I can actually factor out the x plus y. And what am I left with? I'm left with a plus b. And that is going to be how you factor by grouping. So what I have at the top where the green arrow is the same as what I have in the green box. Now, how does that apply to polynomials and actually when you're actually doing it with numbers? Well, here's our example. I want to factor this by grouping. First of all, it's in descending power. It's a cubic polynomial. Now, I'm going to put parentheses around the first two terms, and I'm going to put parentheses around the second two terms. Now, the shortcut, or the way to determine if you can actually group, does this number go into that number by the same amount? Obviously, it's times by 2, and over here it has to be the exact same thing. You notice inside both parentheses are multiples of 2. Oops, I'm going to try and back up here if I can. Doesn't look like it's allowing me to, so I'm just going to use my eraser, and I'm going to erase this. So, since I noticed that in both sets of parentheses, the coefficients are multiples of 2, I'm going to factor out. I can factor out a 3 and an x squared. So I'm going to pull 3x squared out front. Well, what does that leave me? Well, right here, that's going to leave me with x, and right here, that's going to leave me with a plus 2. Because if I redistribute, I will get back what I'm underlining in blue. And now I'm going to do this on the other side. Over here, I'm going to notice I can pull out a negative 4. Well, what's left when I pull out negative 4? This will be an x, and this term over here will also be a plus 2. And again, if I redistribute, negative 4 times x is this, and negative 4 times 2 is negative 8. So therefore, I have, and if you're factoring by grouping, you should have in the parentheses the exact same thing. So what I'm underlining in red is my first factor, and the stuff on the outside I put together, and that will be my second factor. And then you have to check to see if this is factorable, which I don't believe it is, and so therefore I am done. The factors of my polynomial are x plus 2 and 3x squared minus 4, and that is how you factor by grouping. And that's a technique that may work some of the time if you inspect your polynomial. You have to do the inspection first. Inspect it and see, like I was saying before, if these two numbers have a common multiple the same as those. Finally, we're going to talk about a shortcut for factoring quartic trinomials. Now, in order to factor a quartic trinomial, first of all, the x cubed coefficient has to be 0. I'm going to abbreviate. The coefficient has to be 0. And also the x to the first term coefficient has to be 0. And if you notice, that's the case because the x to the third term and the x to the first term are missing. They're not existent. So therefore, this particular factoring technique will work. Now, I'm going to just factor this. You throw in your two sets of parentheses. What goes here and here? Well, if you think when you FOIL, x to the fourth, that's got to be x squared times x squared, because x squared times x squared is x to the fourth. This works just like prior factoring techniques. Now, I look at that sign, it's minus, so one sign's got to be minus and one sign's got to be plus. And then I look at the 25. Well, what multiplies together to give you 25? In this case, it's going to be 5 and 5. Because, oops, I'm sorry. I also have 25 and 1. And 5 and 5 doesn't work. I can check that because that's negative 5 squared, and my outsides are positive 5 squared, which makes 0x squared in the middle, and that doesn't work. So therefore, I need to try something else. And in this particular case, it's going to be 25 and 1 because my insides are negative 25x squared and my outsides are positive 1x squared, which together makes negative 24x squared, which is my middle term. So therefore, I have in the box my two factors of my quartic trinomial, which is in the blue box. Now I got to inspect. Can I still break these down further? Well, x squared plus 1 is not factorable, but I will notice that x squared minus 25 is. And hopefully from our quadratic unit, you know very simply that this is x plus 5 times x minus 5. Upon close inspection, you could figure that out. And then this one, since it's not factorable, just tags along, x squared plus 1. And what I have written in red are the factors of my quartic trinomial, and that is how you can factor a quartic. But the key is the x cubed and the x to the first coefficients have to equal 0. And those are my 3 special cases and shortcuts. And if you have further questions, please ask me during class.